Alright, so we're going to take a look now at parametric differentiation and finding the equation of a tangent to a parametric curve. So this curve here is given parametrically. Parametric means you've got a parameter, which is another variable t that everything's given in terms of. Usually we think of this t as being time. So at a given point in time, so like when it says find the equation of the tangent to the curve when t equals 2, you're usually thinking that that's after 2 seconds has elapsed. What way is the thing traveling? What way is the thing pointing? So what we need to remember for this is that dy dx is dy dt divided by dx dt. So what we need to do is find each of these two things. So let's have a go first at finding dx dt is the first one there. So x equals t plus 1 over t minus 1, and this is going to be a quotient run because we've u over v. So therefore dx dt is v times du dx minus u times dv dx all over v squared. It's coming from the log tables, so I'll presume we don't need to write out the u and du dx this time. So v is t minus 1, du dx is the derivative of this, so that's just 1. U is t plus 1, and dv dx is the derivative of the bottom line, which again is just 1. Okay, differentiate t, you get 1, differentiate minus 1, you get nothing. And then v squared is t plus 1 squared. These brackets are very, very important because it's very easy to get the signs mixed up on the top line. So when you multiply 1 in, you get t minus 1. Now I have a minus here, so I'm going to need to multiply that minus into the t and into the 1. So I'm going to get minus t minus 1. It's astonishing the number of people who make a mistake there. So t minus t is nothing. Minus 1 is minus 2. So that's minus 2 over t minus 1 to be squared. That's the first bit. That's dx dt. We take a look now at dy dt, which is going to be pretty much the same idea. It's a little bit trickier because we have this more complicated bottom line. So in this case we might actually write out u equals 6t, so du dt equals 6, v equals t minus 1 to be squared, so dv dt is twice t minus 1 to be t minus 1 to the power of 1, right? So you have something squared, bring the power down the front, so twice t minus 1 to the power of 1, and you multiply by the derivative of whatever's inside in the bracket, so that's just multiplied by 1. So that's just 2t minus 2. Alright, so let's fill it in then. So dy dt is equal to this formula again, so v times, so t minus 1 to be squared, times du dt, so that's times 6, minus u, that's 6t, times the derivative of the bottom line, so that's twice t minus 1. The whole thing is over t minus 1 squared, squared again, right? So you're squaring the bottom line, so you get a power of 4. Okay, so we're filling in this same formula down here. We're using the u and the v, the du dt and the dv dt that we worked out here. Okay, now there's going to be a little shortcut here. You might spot that on the top line I have a t minus 1 in here and I have a t minus 1 in here. So what, and I also have a t minus 1 on the bottom. So what I'm going to do, which will make life a little bit easier, is I'm going to factor out that t minus 1 from the top line. And I'm going to cancel it then with one of the t minus 1s on the bottom. So if this was 6x squared and I took out an x, I'd be left with 6x in here. Because this is 6t minus 1 squared, if I take out a t minus 1, I'd be left with 6 times t minus 1. Okay, in the second bracket, if I factor out the t minus 1, I'm left with minus 6t by 2. That's it. You can check, if I multiply this into the bracket, I multiply this by this, and I get 6 by t minus 1 squared, which is that. If I multiply this by this, I get exactly what I have there. So what the advantage of doing this is, first of all, I don't have a quadratic on the top line. And also now I can cancel straight away. That t minus 1 leaves me with t minus 1 to the power of 3 on the bottom line. So So multiplying out the top, I get 6t minus 6 minus 12t all over t minus 1 cubed. So that is 6t, so that's minus 6t minus 6 all over t minus 1 cubed. Alright, so let's take a look at dy dx then. Alright, so for dy dx, it's dy dt over dx dt. So that's minus 6t minus 6 over t minus 1 to be cubed divided by minus 2 over t minus 1 squared divided by this thing. And the easiest way to do this is to invert and multiply. To be cubed multiplied by t minus 1 to be squared over minus 2. Now straight away this and this cancel and I'm left with t minus 1. At this stage you might look at that top line and say, well look, I could factor out a minus 6. Hopefully you look at that top line and say I could factor out a minus 6. So you get minus 6 into t plus 1 all over t minus 1 by minus 2. There's a little bit of cancelling here. And actually what you can see is that in this case, and this is pretty unusual, in this case we get 3 times t plus 1 over t minus 1, and t plus 1 over t minus 1 is actually x if you look back up to the top. So in this case that's actually equal to 3 times dx value. Okay, so dy dx, the slope of the tangent is 3 times dx value. Alright, let's have a look then at how we would find the equation of the tangent. So we'll get rid of that. Alright then, finding the equation of the tangent. So the equation of the tangent we should know is y minus y1 equals m into x minus x1. Alright. We are interested in the equation of the tangent when t equals 2. Alright, so when t equals 2, we can't find, well actually we could look at this and we could find the slope of the tangent here. Right, so the slope of the tangent, which is dy dx, if we go up to here, it's 3 times t plus 1 over t minus 1. So when t is 2, that's 3 times 2 plus 1 over 2 minus 1. So that's 3 times 3 over 1, so that's equal to 9. So the slope of the tangent in this case is going to be 9. Alright, in order to find the equation of the tangent, we now need to find what x and y are. So to find what x and y are, we go right back up to the start, up here where a curve is defined by x and y. So x equals t plus 1 over t minus 1, which is 2 plus 1 over 2 minus 1, which is 3 over 1, which is 3. And y is equal to 6t over t minus 1 to be squared, which is 6 times 2 over 2 minus 1 squared, which is 12 over 1, which is 12. So the point that we're looking at is the point 3, 12. So now we can go and we can find the equation of the line. It's just worth mentioning that if we hadn't got this, the slope of the tangent, we could find x and find y, and then looking back up here, the slope of the tangent is actually 3 times x. So it's actually 3 times 3, which is 9. So we didn't have to fill that in there, but it's no harm if you do. So finally, the equation of the tangent. This particular point is y minus 12 equals 9 into x minus 3, and we just multiply in and tidy up. So y minus 12 equals 9x minus 27. So say for instance we get everything to the right hand side, you'd end up with 9x minus y. So that's a plus, so you end up with minus 15. And that there is the equation of the tangent. Okay, so just to run through this very quickly once more. Whenever you're asked in a differentiation question to find the equation of a tangent, you're going to need to find dy dx, because dy dx gives you the slope of the tangent. Right, so once more, write down dy dx gives you So with parametric equation, you find the slope of the tangent by finding dy dt and dx dt and 1 over it. Alright, so we find dx dt first, we found that first here. For dy dt was a little bit trickier, you just have to be careful when you're differentiating that bottom line. Okay, so you bring down the 2, you get 2 times t minus 1 to the power of 1 multiplied by 1. So that's 2 times t minus 1. Now with this top line, maybe I'll just go do it there at the end. With this top line, you don't have to spot what this spot is. It just makes life easier. Okay. If you do spot it, you can factor it out, cancel straight away, and you end up with this nice thing. If you don't spot it, what will happen is you'll end up solving a quadratic, and one of the factors will be t minus 1. When you go to put the two results together to get dy dx, it's dy dt over dx dt, and the easiest way to do this is invert and multiply. So turn the bottom line upside down and multiply. You can see there's quite a bit of cancelling. You can leave your answer as 3 by t plus 1 over t minus 1 if you like, or you can leave your answer as 3x. Now if the question said give your answer in terms of x, you'd have to leave it at 3x. Okay. From there to the end, it's a case of filling in the value of t that you're asked for. So we're asked for when t is 2, so you fill that in everywhere. Fill that in to find x, fill that in to find y, fill that in to find z. Okay. Just as kind of an aside, and just to show you that you can do it, we're going to go back to here, and we're going to multiply this out and show that you can solve the equation. Alright, so we've got dy dt equals t minus 1 by t minus, oops, sorry. Dy dt equals t minus 1 by t minus 1, this is t minus 1 squared by 6 minus 6t into 2t minus 2. So all we've done there is written out the t minus 1 squared is that we multiply the 2 into a bracket all over t minus 1 to the power of 4. Alright, so let's multiply these two together. So you get t squared minus 2t plus 1 by 6. We'll multiply them, t by t is t squared minus t minus another t minus 2t plus 1 by 6. When I multiply this in, I get minus 12t squared plus 12t over t minus 1 to the power of 4. When multiplying, you get 6t squared minus 12t plus 6 minus 12t squared plus 12t all over t minus 1 to the power of 4. Now these actually cancel. So the minus 12t and the plus 12t cancel. So I end up with minus 6t squared plus 6 all over t minus 1 to the power of 4. Now hopefully you spot that I could factor out a t or a 6 for that, and I get 6 into, if I write this the other way around, if I put the plus first, I get 1 minus t squared. Is that alright? So it's as if I've written this one first, so 6 minus 6t squared. Alright? And the advantage of doing that is that it looks like the difference of two squares. It's easier to recognize. So the only tricky bit here is to spot the relation between these two. Okay, so t minus 1 is actually minus, sorry, 1 minus t is actually minus t minus 1. You can check if you multiply this in, you get minus t plus 1. Alright, minus t plus 1. So this is the same as that. So now if I cancel this, the bottom line, we might go up here to do it, just so we don't have to go into a whole new page. So if I cancel this with the bottom line, I'll be left with the 6 on the top line. Now when t minus 1 goes into this, it leaves me with it goes in minus 1 times. And on the bottom, I'm left with t minus 1 cubed. So you're left with minus 6 into 1 plus t over t minus 1 to be cubed. Exactly what we had here, and this line we just wrote it slightly differently. You can see that if you multiply out this top line here, you get minus 6t, and that's exactly what we had up here. Okay, we have the factorizing done down here, which means when we get to this stage here, we won't have to do any more factorizing. So you can do it. Okay, and it will work out perfectly fine. So if you're not happy factoring out the t minus 1, just multiply everything out.